Hi guys, welcome back to another exciting episode of Science with Mr. Jacobs. I'm Mr. Jacobs. This stuff is science, and today we're going to continue learning about gases. And as always, if you feel like you've learned something or you just like what you heard, feel free to give a like and a subscribe down below. Today we're going to be looking at gases, and we're going to be kind of seeing what happens when we do a couple different things to it. The first thing that we have is we have two syringes connected together by this tube. I have one plunger sticking out on one end, and I have the plunger pushed all the way in on the other. So what do you guys think is going to happen when I go to push on this end? Let's find out. So when I push on this end, it pushes it out over here. But what if I turn it upside down and do it again? Oh, man. I feel like I could keep doing this forever. So when we push on one plunger, it pushes the other plunger back out. Interesting. All right. But what if, now, I'm curious, what if both plungers were pulled all the way out and we tried to push them down at the exact same time? Ooh, it's getting kind of hard. Oh. And we created enough pressure inside that it shot the tube off. That's kind of interesting. So there's only so much compression that this system could take before it eventually needed to release some of that air. Well, since we have them both down, let's see what happens when we try to pull on both of these plungers. This is way easier with two people. I know you can't really see it, but that, the tube starts to get really, really thin when I try to pull on both of these plungers. Maybe I can get it this way. Yeah, that tube has like compressed all the way flat on itself, and then when I go to release these, they both kind of shoot back. So it doesn't feel like they like to be, have that air expanded on them. That's pretty neat. All right, so the next thing we're gonna look at, and we kind of looked at this yesterday, or in that previous video, is what happens when we have a syringe with just a clamp. So, since the first thing on our sheet says compress, I'm going to go ahead and clamp my syringe shut, that tube shut. There we go. And compression. It does start to get a little bit harder to press down around that 12, 13 milliliter range. And then it does kind of like to bounce right back to where it was. We need to see what happens when it expands. So let's go ahead, let's push it all the way in. And we are going to try to expand this gas so we can make it fill the entire syringe. However, it is causing me to strain just a little bit. So as we go to release this plunger, it does shoot all the way back in. Interesting. The next one that we're going to be looking at is this blue cube. This blue cube is about 1 centimeter by 1 centimeter by 1 centimeter, so it's just a nice little square. It's going to look like this guy. There's no holes on the outside, it's just a completely solid blue cube. And I've already gone ahead and put it inside of this plunger, or inside this syringe. So we need to see what happens when we compress it. So I'm going to be watching this blue cube. It starts to get a little bit smaller, and you guys can really kind of see it if you can get up close. That blue cube has gotten significantly smaller. And then when we kind of let it go back to that normal air pressure inside there, that blue cube does go back to its full size. So now we need to see what happens when we try to expand it. So I'm going to press it until the cube is just touching the walls. And what do you guys think is going to happen when we try to expand it, knowing what happened when we compressed it? Oh, really? All right. Let's see if that happens. So we're going to try to expand it. And it does look like it got a little bit bigger. Does that match your hypothesis, what you were wondering? Yeah, and then it kind of goes back to that normal size. Interesting. So the blue cube got smaller when we compressed it, decreased in volume, and then it got bigger when we were giving it more room when we were trying to expand it. Interesting. Our next one that we're going to be checking is this gray cube. These gray cubes. They got holes everywhere. It kind of looks like a Swiss cheese of cubes, if you will. So we got holes everywhere. It's pretty squishy. We're set up again to compress it, which is again that decrease in volume caused by an outside force. What do you guys think is going to happen when we try to compress the gray cube? Interesting. Let's find out. Huh. Nothing really happened. It kind of just went back to its normal state again. Interesting. All right. So let's see what happens when we try to expand it then. So nothing really happened when we compressed it. What do you guys think is going to happen this time when we try to expand it? Interesting. Let's find out. Again, not a whole lot changing. Just kind of stayed there. It didn't really get bigger or smaller per se. Just kind of stayed the same. Huh. I wonder if that's because of all the holes that the gray cube has in it, whereas the blue one doesn't. Maybe when we're trying to expand it and compress it, the air is able to like flow through all those holes and it's just able to kind of move around and do its thing. Whereas on the blue cube, it actually like applied force to that solid shape and didn't really like, because it's solid, it didn't let the air flow through it so it would change its size. Huh. All right. Well, let's move on to our bubble wrap. So we got a little piece of bubble here. I'm not going to try to pop it, but we got a little bubble. Now, which one do you guys think the bubble is more like? Do you think it's more like the gray cube or the blue cube? All right. Let's see. Let's find out if it behaves the same way as the one that you thought. All right, so we are set up to compress. And it looks like the bubble is starting to deflate. It's kind of looking flattened. It did get quite a bit smaller. Okay, interesting. Did that behave how you thought it would? All right, let's set up for expansion. All right. Oh, the bubble's inflating. It's like stretched all the way. Oh my goodness. Yeah. Got it fully inflated. Huh. So the bubble behaved very similar to the blue cube. When we went to compress it, it got smaller. When we expanded it, it got bigger. Inflated, expanded. Huh. Interesting. So we've learned that gases can be compressed and expanded today. And depending on what they're pressing on, they'll either flow through it, like the gray cube, or they'll kind of exert that pressure and either compress that shape, that solid shape, into something smaller or bigger, depending on what we're trying to do. Interesting stuff, guys. I'll see you again later.